Okay, so today in Advanced Topics in Networking, we are going to be discussing around few different concepts around software-driven networking. So SDNs, software-defined networking, network function virtualization, SD-WAN, so things like that. So to start with, when we think about computing systems and networking from a sort of a traditional standpoint of how things used to be, the traditional architecture was largely a vertically integrated system with a significant amount of proprietary hardware, software components, and traditionally, the focus was on reliability and performance. It still is, but that was a particular focus. To say like connectivity and networking was not always the priority. It has become a priority in the last couple of decades, but it has not been the primary driver all along with computing. But with sort of the traditional computing paradigm, we also see number of sort of limitations that it has because of the nature of how these vertically integrated systems, things are integrated together, or proprietary operating systems and software systems. Quite a lot of vendor lock-in. So that is to say, we are dedicated or like we are locked in with a particular vendor. So for example, we are buying things from Cisco or HP, and now all the routers and switches and everything in our environment is Cisco. And if we want to replace something, we need to get a new Cisco because that's the only way they can talk to each other or work with each other. So that sort of creates this small closed ecosystem for technologies and different systems that we can use in our environment. That in turn then creates this bottleneck or a roadblock when we want to expand, bring in new things, experiment or implement new technologies, be it hardware or software wise, or if we are to like scale up, grow into a larger environment, larger organization, again, there could be a number of limitations because of these things as well. So even like you can think about some examples of any sort of proprietary systems that can slow down innovation. So it could be around like, yeah, doesn't have to be networking per se. Like there are many sort of technological areas where proprietary systems or like locked in sort of systems can create this roadblock into like innovation. So that's something I would encourage you to think about as well. So now if we sort of go back to last week's sort of discussion on sort of network control planes, or network sort of looking at networking in sort of this layered structure. So when we think about the traditional network architecture, so this is where we have the data plane, control plane, and management plane. We have the packet forwarding and all those things happening in the data plane. We have routing happening in the control plane, and sort of devices being managed, devices being administration, and all that happening in the management plane. But with this sort of a structure, there are certain limitations that we would see. One is there is a significant tight coupling between control and data planes, because again, if we sort of go back to last week's discussion where And many a times these two things would exist in the same device. So a router would have the data plane functions and the control plane functions, and both of those things would exist in the same device. So there's a significant sort of tight coupling in how those things are implemented and how those things function. And in many times these would be proprietary systems. So a Cisco router would have its own way of implementing these functionalities compared to an HP router or any other sort of vendor's router. They would have a different way of implementing or different way they would have implemented within their devices. And most of the time it would be a proprietary technology, a way of implementing that. And that in turn would also have significant sort of limitations with flexibility in terms of how we can um, use them, control them, sort of, and also like programmatically control them. So then that again leads to this issue around like automation or lack of ability to automate things, or the complexities that come about with vendor lock-in and the need to stick to a single vendor and things like that. So if you again like sort of recap some of the things that we discussed last week in terms of this layered architecture. So this is where, again, like we have the infrastructure layer or the data plane. So this is where the actual packets going about in our physical infrastructure. Then the control layer is the control plane is where we are maintaining routing tables and like whether it could be sort of internal routing or it could be WAN routing. So any of those things can happen there. And then the application layer, the management plane, is where we configure things in our devices. We do monitoring through this. So any access control and all these other additional things that we do within our devices, we would use or do through this. So now when we think about these traditional networking technologies or network technologies that existed, there are, we can sort of identify a few different limitations or few key limitations with these technologies. So the first one being it could be around the legacy infrastructure. So that is to say, so the modern networks would require sort of a diverse nature of networking devices to interoperate within an environment, whereas a lot of the legacy infrastructures would not be able to better cater to that type of a requirement. And sort of the requirement to have specific or protocols and things like that. Vendor lock-in, again, like as we discussed, the proprietary systems that we use may require like difficulty integrating things from different vendors, and also automating those integrations in sort of modern cloud environments would be a challenge as well. And then from an operational point of view, again, many of these network configurations or way we configure these devices would require like specific knowledge and specific skill set to do that. So for example, like again, like if you think about like some of your previous courses in networking and some of the laboratory lessons you would have had around configuring routers and switches and so on. And if you are doing that through a command line interface, you would have used certain commands that are proprietary, specific to a particular vendor. So like say Cisco, they would have specific command sets that you would use to configure their devices in a particular way, and that may differ to a particular another vendor. Device from another vendor would do that significantly differently. So that would be that becomes a limitation or a challenge as well with the traditional way of using these technologies. And with that, like it can also create sort of additional sort of limitations, or like from that, these things can also result in limitations with scalability or ability to scale up our network. Again, these things can impact that. Automation barriers, as we discussed, so that can be there. Um, and also, like one of the other factors that could be a challenge would be human error, like other human factors. One, like we need to have specific skilled people in our organization if we are to bring in like two different uh, types of devices, or these people need to upskill or reskill to a different type of device if we are moving to a different vendor. So that again, sort of this multi-layered sort of limitation as well in that sense. So with that, like we can sort of further sort of identify some of these challenges, these networking paradigms sort of pose in sort of enterprise environments, networking environments. So many of the traditional way of networking would be static in the sense the way the infrastructure is interconnected would be very static or fixed. So the hardware, and particularly the hardware components, would be interconnected in a particular way, and they would only be able to function in that particular manner that we have interconnected and configured them. And they would not be able to sort of adapt to sort of dynamic workloads. Say, for example, if there's a particular high traffic requirement happening in a particular in a specific area of our network, we may not be able to sort of anyway sort of restructure that network environment other than actually physically making some changes, because there's a significant coupling with the physical infrastructure there. And another sort of challenge is, again, that we sort of briefly touched on is around scalability. And again, when we need to scale up, the requirement becomes we manually provision additional components or upgrade the hardware, which can again be costly. So there, when we have the need to scale up, it becomes additional challenges would come about with that around hardware challenges, the physical infrastructure challenges, all that would also be connected to that. And as we discussed, management is a significant pain with these networking um, approaches, particularly with command line interfaces for configuring, which can be laborious and also error prone. And like you would be familiar with trying to configure things, and like unless you know and or like even minor errors can, or minor mistakes can lead to major errors in configurations. And interoperability, again, like this ability to work with different systems or different systems talking to each other. Again, that limitations is there. And one of the other particular factor would be around cost. And this would be both with CapEx, or the capital expenditure, but also operational expenditure. So capital expenditure is when the cost that would be involved in buying the hardware. So say we need to buy the routers and switches and firewall and all these components that we are buying. There would be a particular significant cost that would be there. But then if we are to like, when we use them, we would have additional costs for maintaining them, upgrading them. So then those are the operational costs. And with many sort of traditional way of doing things or devices or the approaches of using these or setting up these networks, both of these things can be particularly costly. CapEx would be costly, obviously, because it's a significant upfront investment in buying these things. But also there could be significant ongoing costs in terms of maintenance and people to maintain these things and potential upgrades when we need to scale up or like all those things. So again, it could be costly as well. So that could be a particular challenge here as well. We will revisit this a little later in the discussion today to see like how software-driven approaches can mitigate or like address some of these challenges as well. So now if we think about like say from the traditional computing paradigm and transitioning into a more cloud-centric computing paradigm, so cloud computing paradigm, we will see like, so when you think about like an application that you run on your local server and you want to put it in a cloud environment, generally moving an application into a cloud environment doesn't have to be significantly challenging because you can set up a similar computing environment, application, OS, and all that, database, blah, blah. And now all those things can be very easily replicated in a cloud environment and you can get things going in that way. But when we think about larger migration of a whole data center from a traditional networking environment into a cloud environment, now it becomes much more complex because now we are not only thinking about a single computing device, a server that exists in the physical world into a cloud environment, still a physical world. But particularly when we focus on the networking aspects here, there are a number of things that we need to now have in our cloud environment that we would usually have in our like sort of networking environment. So when we think about a traditional sort of environment, data center, so to speak, and in that we would have like web servers with fronted by load balancers. We can have additional firewalls. We can have mail servers, proxies. So these are sort of various things that can exist in such an environment. So all of these things we need to now move into a cloud environment and be able to interconnect them in a similar way that we would be able to achieve the same level of control that we can in our traditional data center. So we can move, say, one-on-one like a server from our data center, we can move to a cloud server that we can do. But from a networking point of view, we would ideally expect to create a similar controlled access to these assets or resources in our cloud counterpart as well. So that it doesn't matter whether they existed in our physical data center here or they are now moved to the cloud. We would want them to be in a similar way in terms of how they are interconnected. So this is where we would come to some of these challenges around virtualization. How do we virtualize some of these network components? And how do we bring them about in this cloud environment, cloud native environment? So this is where we are required to create some of these physical equivalents or the cloud equivalents to some of these physical network appliances like a router or a switch. How can that be there in our cloud environment? So this is where we think of this decoupling of the network layers or the network control plane and all that. And this is where software-defined networking comes into play as well. So from an application layer point of view, the management point of view, if you think about a cloud environment, let's say we take AWS or Azure, like one of these cloud vendors, just as an example. Whatever that you do in those environments, you set up virtual machines, you connect between your virtual machines, you can do all those things. But you are never interacting with anything physical in that environment. You are never interacting with any physical devices or any of those things. And same thing with a lot of the admins as well, like because like all of those things are now managed via software and they are abstracted or like we are given certain APIs that we can manage those things through. And SDN sort of virtualizes the the different sort of physical networking functions that we would usually have in this sort of cloud environment. And this also creates this modular network design, so where different functions can exist independently of the actual devices and the underlying infrastructure, and we are able to make sort of the equivalent of what we would have in a traditional environment in a cloud environment. So now if we go back to this, our sort of traditional data center stack that we had. So we had the um, web servers, mail servers, so different servers. We have the firewalls, proxy, all those things, and an intrusion detection system or like that type of thing. So there could be like quite a few different things that exist in our traditional network stack. But the main thing is all of these devices are going to be physical devices. So we have a physical firewall appliance. We could have a mail server, which is a physical server. Then whatever the interconnectivity we have, so we need to configure those things and all that. And most of these configurations would need to be manual as well. So if we add a new web server there, we bring in an actual server, put it in a network rack, we connect that and make any configurations in our router so that that fits in the same, or the firewall sort of allows same type of traffic to that web server as well. Now, when we move these things or move into our sort of cloud sort of era, now all of those things can sort of come in sort of a virtualized equivalent of all of these things. So we would have a virtual router, we can have a virtual firewall, so all of those things. And all of them could be controlled through a software-defined networking controller or SDN controller. And these things can be additionally, these can be dynamically provisioned. So like similar to how you would go and create a virtual machine on a cloud provider, like when you create a virtual machine, nothing changes in the physical world. All the existing things in their data center is still the same, but you get a new server that you can use like a server. So similarly, a lot of these additional networking components can also be virtually provisioned. So for example, we can virtually provision a router and then connect a number of our devices to that router, again, all virtually happening. So in this case, SDN or software-defined networking essentially abstracts our physical infrastructure into this programmable sort of environment, which then later we can use for additional automation, scaling, and all that. So for sort of a modern networking environment, what are sort of some of the key things that we would expect it to have? So we would want to have, first thing we want to have would be hardware software decoupling. So that is, we are not particularly dependent on a specific hardware or locked in or like interconnected with the hardware in terms of what we do with it. So each of the layers can operate independently, so we can use it as we need. Then having standardized interfaces, so not having sort of vendor specific way of talking to each other, but have more standardized ways of interconnecting and talking with each other. and then sort of abstracting each of these layers so then they can be programmatically controlled and automation can happen and all that. So that's essentially sort of the vision or like what we try to do with SDNs. So like a modern, like a particularly open and programmable network architecture. So that brings us to software-defined networking or SDN. So SDN is essentially, again, like we briefly touched upon this last week. So it essentially, the main thing that we think here is the separation of the control plane and the data plane and then centralizing that control plane. So not just separating them within the device, but rather taking it out and then centralizing that control plane so then it can be controlled centrally, essentially. So in a traditional networking, we have all these appliances and they are interconnected as we usually do. But in an SDN network, software-defined networking, we would have the SDN controller, and then that would do all the different functions like routing algorithms, IDS functions, load balancing functions. All of these network applications can run on top of that separately together, so that can be configured or like done in any way, but like the main thing is now all those functions are in a particular centralized place rather than on a per device basis. So one of the main things to remember is even though when we think about software-defined networking, it doesn't purely replace the physical network. We still need to have the physical network so the underlying infrastructure is still connected and we can communicate to it. But it creates a virtual overlay network. So the physical infrastructure and it will have a particular connectivity. So all those things will be there. But then we create an overlay network on top of that, and that's what we would control. And the second key one is the centralized control of it. So now all the traffic flow can be controlled through a single point or a central point, essentially. And many of these things can be programmatically controlled. So again, like based on our requirements or needs or like say scaling requirements for addressing traffic sort of peaks. Again, like we can scale up, add more functionality or add more sort of capacity and scale down and all that. And those things can be done programmatically or automatically. And the main benefits that we would get from this is, again, these would sort of correlate to some of the challenges we would have. We sort of discussed with traditional networks, simplified network management and automation, scalability. Again, we discussed that, and integration with sort of other sort of virtualized things. Say, now we have a virtual server, and when we have a virtual router, then we can connect those things and do, because if our servers are in our virtual environment, we would ideally want to have our network functions also in that virtual environment. So those can be managed in a sort of similar way. So that's what we can do with SDN. So again, like if you think about the sort of the architecture of the traditional sort of networks. So this is what we had, the data plane and the control plane and management plane in our sort of traditional network. Whereas in an SDN environment, again, we have the network infrastructure still there. Then we have the interface between that and the SDN controller, which is the southbound interface. Then we have the functions within SDN or the network appliance. Then we have functions that enable interface to external control, so that is the APIs through the northbound interface. So again, like we can have the routing and access control and all those things here. Then they come into our network virtualization, and then they come to the actual physical network. So with SDN, so like now when we think about the key components that we have, so we have so in terms of the architecture, if we again look at this, we have the data planes, or the actual underlying infrastructure is there. Then we have the southbound interface, which is the one that is interconnecting the physical layer, the physical infrastructure to our SDN controller. Then we have the northbound interface, which is through APIs we connect to the applications that we use. So this is where we have the applications. So these are the different applications that we can use to define the way that we want the network to function. So this is where we can set QoS or like quality of service or security policies, access control, routing, and all that we can set through that. Then the SDN controller is essentially the central component or the key component of this whole thing. It is, we can say it's the brain of the whole function, and it translates sort of what the application wants. That is the intent of the application or the users, and then translates that into device level instructions in terms of what needs to happen in the data plane, where a packet from where needs to go to where. So that's what would be done by the SDN controller. And this is the one that would manage and make sure like whatever that happens within the data plane is also visible to the application, so then we can have visibility in both ways, or in this way and control this way. Then we have the network devices. So these are the routers and switches that we would need to have in our environment. And on top of all of these, many of the SDN environments would make use of a number of open source technologies. Particularly OpenFlow is one of the standard protocols for controller device communication. But other than this, there's a number of other technologies as well that would be used in SDN environments. So if we go to particularly sort of think about sort of different technologies, again, like we will not go into any sort of detailed discussions into any of these technologies because those are very specific use cases in terms of where you may end up using them. But just to have an understanding, there are a number of different technologies that would come into play when we think about the overall SDN environment. So we need to have the infrastructure. So these are the virtual switches that would interconnect between the data plane. Then we have the southbound interfaces. So these are the protocols that communicate between the controller and the device. So that's where OpenFlow comes into play. Then the northbound interfaces, these are the interfaces or the APIs between the SDN controller and the applications. Then network operating systems. So these are the ones that run in the SDNs. So that's where we build and manage the SDN controllers. Then network virtualization technology. So this is where we could use to create the overlay networks in a way that we want, that doesn't have to correspond to the physical network. Then there are a number of specific programming languages that can be used to define network policies and what needs to happen in the network and all that. And then whatever the networking applications that we can have on top of that. So these could be traffic engineering applications, QoS applications, monitoring, security related applications. So there could be different ones doing different things. So again, like there's no need to go into anything specific or any of these specific things at this stage unless you are in a place of using them. So that's where you would ideally go about learning and using these things because they are very specific applications. But of these, one of the ones that would be good to know or like good to have some level of understanding would be OpenFlow, given how it's one of the more prominent ones among these in terms of technologies that you could learn about. So when we think about SDNs and some of the key advantages of SDNs, so the flexible architecture is something that we discuss, so that is the decoupling of the control and data plane. That's sort of the main thing that we get out of this. And that also gives us this scalability advantage. So that is, again, dynamically, not just scalability, but also the dynamic scalability. So this is where when we have changed traffic patterns, we are able to address those demands. So again, like if we go back to when we were sort of discussing about traditional networks and like if we have significantly increased traffic demands, it would be a challenging task to suddenly sort of increase that capacity in our network environment versus if we are able to do this sort of programmatically. Then sort of automated management, again, like because we have this centralized control, we are able to configure things centrally and sort of monitor them, but also a lot of the configurations can be automated because say if we create a new device of a particular type, we can say like what are the firewall roles to that and all that can be automated. And one of the other important one is particularly around when we were talking about vendor lock-in and all that, the interoperability, because like now we are able to sort of interconnect diverse sort of hardware platforms because now we are mainly using open standards and APIs. As long as they are able to talk through those APIs and standards, we are able to interconnect sort of these different vendor platforms and technologies and devices. That also, all of these things can also contribute to sort of cost efficiencies. Again, like when we discussed about sort of the capex costs and sort of capital expenditures and operational expenditures, using sort of non-vendor specific hardware, but rather more rather than sort of proprietary devices and all that, when we go through this approach, we are able to sort of have significant cost advantages as well. So as sort of an anecdotal story around how SDNs or like how some of these transitions from traditional way of sort of doing things, particularly around scalability, I have like number of years ago, I used to work at an organization with that we were like servicing telcos or like telecom operators and providing them with SMS centers and like messaging centers and all that for the telecom operators. So this is many years ago, like I think would be like 15 years, like yeah, around 15 years ago from now. So this is before a lot of like WhatsApp and social media. Like this was like very early in days of Facebook as well. So most of there was SMS messaging was still a big thing, and that also meant there were particular times of the year where the traffic demands to the SMS servers would be significantly high. One of the main ones would be the new year, like 31st of December, 1st January, that midnight. And the way that we had to do scaling in that environment is we would need to take a additional physical server, two servers. So we were mainly servicing Dialog and Mobitel. So for Dialog, we would give two additional servers, and for Mobitel, we would give two. And I think for another one, like one, I think. So there was like about 5 additional servers, each to their own data centers. So we would take them, deploy them like 3 or 4 days before that peak that we are expecting, because we didn't have any other way of scaling or virtualizing and deploying additional devices. We had to do that physically and interconnect them in their data centers. And now we have, instead of load balancing to like 3 servers that they usually use, we have 5 now or something like that. And then 1 week after that peak has completed, they no longer need that additional capacity. So we can go and decommission those 2 additional devices, take it back, and use it like that. So so that's how things had to be done at some point in time, instead of like spinning up a new virtual machine and deploying that same thing, same script, deployment script, and that creates a new SMS server, like whatever the server is, like, and now we can have additional loads to load balance into that server these days. So that's sort of just as an example from my experience from a traditional way of doing things and how we would do those things, do a similar thing these days. So when we think about software-defined networking, I can ask a question that is, does having SDNs, does it simplify network security or does it complicate network security? So is it good for network security or is it creating more problems in terms of network security? And we can think about that, particularly from these 2 concepts around centralization and attack surface. So does anybody know what an attack surface is in terms of security? So when we think about an attack surface from a security point of view, it's essentially like the number of places that can be attacked. So when we think about traditional networking environment, if we had like 5 different routers, then we have these 5 different places that can be attacked. So that's like the attack surface is larger. On the other hand, when we think about SDNs, now all of these things are centralized, so now it's a single point of failure. So that's also not good. So having less attack surface is not always good because sometimes it can be a single point of failure. But like if we go back and think about some of the security aspects of SDNs, one of the main things that we can gain for security through SDNs is the centralized policy management. Because SDN controllers are centralized and they can enforce a lot of the security policies across the network centrally. So we don't need to go into each of the network appliances and specifically configure different security policies on an each device basis, we can control them centrally, and then they can be enforced through the SDN controller. So that also simplifies any sort of process around updating security policies and also maintaining the consistency across the devices and things that we have. Then we would also have efficient segmentation between endpoints. So the different users or different endpoints that connect to our network, we can more specifically segment. Say, for example, we can say like in a university, and well, let's take a university as an example. So we can segment the network and like group people into, or group devices into, some of these are laboratory devices, some of these are other sort of servers in the that are within the laboratories. We can have staff, we can have students, we can have wireless access points and all that. So we can have segment, and we can sometimes even further micro segment within the environments as well. Say this is a particular specific lab that needs higher latency traffic because they use particular functions or they have particular demands there. Then one of the other things that we can do in terms of configurations when we use SDNs is business aligned configuration. So this is where we can have policies that can be based on the business logic. So this is examples can be roles of users or applications of different things. Say, for example, students connecting to our network in a university can do certain things and cannot do certain things, compared to staff connecting to the same network can do certain things and not do certain things. So these things are business specific configurations, as in like it's a business logic that determines who does what. And those configurations can be much better done through SDNs. And then that also means we don't have to rely on a lot of static configurations, IP-based configurations and things like that. But one of the main security considerations in terms of when we are using SDNs is also the need for us to use secure communication when we are using SDNs and configuring and controlling and managing SDNs. So this is where, again, like transport layer security and role-based access control, these things come into play. So because, again, that centralized nature also becomes a single point of failure. So there's a higher requirement to make or ensuring security of that SDN controller. So again, we need to have additional considerations in when managing them. So now, if we think about, again, SDNs and think about security challenges for SDNs. So earlier we talked about some of the advantages, additional security things that we can do. But now let's think about some of the security problems or challenges that we would have with SDNs. So again, like we can go back to the same question around like how like centralization in SDN can both improve security, but also complicate security. So this is where, again, the centralized control makes SDN controllers a high value target for DOS attacks or hijacking. Then, because like now we have decoupled our overall network and there are sort of multiple layers of network, there's this additional communication happening between these different layers. So that is the SDN controller is talking to the devices, it's also talking to the applications, and there are APIs and interfaces to communicate with each other. And some of these communications, if unsecured, they can be vulnerable to hijacking and spoofing type attacks as well. Then also like at the underlying physical infrastructure, physical data plane level, it's also possible for malicious devices to come into the network. So like if somebody comes in and plugs in an additional switch into the network, and if that manages to manipulate the traffic flows, then that can be a risk as well. And also one of the other challenges is like also one of the advantages that we discussed is around these standards and interoperability between different vendors. But the challenge is not all of those things would be implemented as expected. So the implementations can sometimes be inconsistent across vendors. So sometimes we may not be able to have a unified security practice because some of the devices may not implement particular protocol or particular functionality. So now we are not able to use that capability. So if you think about the ways that we can mitigate these security challenges, the first one would be the use of distributed control. So rather than having a single point of failure, if we can have load balanced distributed controllers, it would be possible to fail safe to one to the other if one fails and so on. And then enforcing transport level security for any API communications, having role-based access control in terms of who can access the SDN controller and manage and make change to configurations and so on, and then having additional functionalities around monitoring and anomaly detection and so on. So traditional security functions, again, we would do some of those in SDN environments as well. So when we think about where we can use SDNs, we can pretty much use SDNs in anywhere. But there are certain places or certain applications that would have significant benefit in using SDNs. So first one is around in data centers. So this is where we can have SDNs for centralized traffic control. We can then, within our data center environments, we can do dynamic resource allocations or so dynamic provisioning, deprovisioning, and all that. So that's one place, data centers, that's one place where we can use and it can be beneficial. It can be also beneficial in sort of larger campus environments or large enterprise campus environments. This is where we can use functionalities like policy-based segmentation between departments, between different parts of the organization. And some of these can also be used in conjunction with bring your own devices and IoT devices, and how do we manage those things as well. Another place is carrier networks or telco networks. So it can be in sort of 5G broadband type network environments. And some of the functionalities that can benefit in these environments would be, again, dynamic bandwidth allocations, making changes in terms of the requirements of different service requirements. And another sort of different type of benefit would be around disaster recovery and failover. So this is where a lot of the automatic rerouting type functions or benefits that we get from SDNs would be beneficial. So if one part of the network fails, then how are we able to sort of recover from that and switch to a failover option that we have. So this is where we can do sort of real-time reconfigurations for like our availability requirements that we have. And Lastly, like one of the other things, particularly when we think about sort of a lot of the public cloud, public-private cloud, hybrid cloud type environments, uh, this is where we can have interconnectivity between multi-cloud or multi-tenant cloud networks, and the ability to interconnect between different tenancies and like things of that nature. Again, sort of not just thinking about a single environment, but thinking about multiple tenancies in cloud environments and interconnecting them. Again, SDNs can better cater to those requirements as well. So just to recap some of the differences, like um, the main thing is like around control, and sort of again like the centralized versus distributor, like device specific. Main advantage with SDNs is around again like scaling and um, uh, programmable nature of it. And also cost becomes a particular factor as well when we think about this. But there are also a number of other differentiations as listed here. But these are things that we have already discussed in previous slides. And sort of before going into the next topic, finally on SDNs, again, like when we think about sort of future trends, this would be a recurring theme in most of the other topics that we have in this course as well. Like when we think about future trends, a lot of them would have AR, AI, ML aspects. So again, like SDNs can utilize a number of these things as well, like um, uh, any of any functions, any sort of the anomaly detections, predictive pattern detections, and all that. But another sort of interesting one is intent-based networking. So that's where we identify the business intent of a particular network communication and then apply particular configurations or requirements based on that. Then there's quite a lot of places where SDNs can again be utilized in 5G and edge computing type applications. And then also like many enterprise environments these days like are have moved or like in the process of thinking about zero trust architectures with regards to security. And that can also apply to networking environments and SDNs. And how do we bring about some of these additional granular access controls into SDN environments? And then sort of some are like programmable data planes and cloud native SDN. So these are additional sort of things that are coming about as well. So that's SDNs. And now we will move on to network function virtualization. So what is network function virtualization or NFV? So it essentially virtualizing any of the network functions and running them as software on virtual machines. So I'm not sure like any of you are familiar with like there's like even on personal level it's fairly common or not common but like practical for us to use like a virtual like set up a machine like a server and some virtual machines, and then on one of the virtual machines run a router software, and then that virtual machine router can be the router instead of an actual router, physical router device. So like something like OpenSense or PFSense or something that can run on a virtual machine can be a router as long as we have the required networking, physical connectivity, and then map those things into our virtual machine, then we are able to use that particular device as a router. It doesn't have to be a router looking router. It can be a computer, PC, anything. So that's essentially network function virtualization. So whatever the software that would run on a proprietary hardware normally, like say a Cisco router would run a particular Cisco routing software, router software on that particular device. Not that, but a similar software that can do similar functions can now be deployed on a virtual machine. And then we would get all the benefits and advantages of whatever that we can get from this type of virtualization. So one of the main advantages with this approach would be the cost efficiency. So instead of having, say, number of different network function appliances, we can bring about all of them into different virtual machines and possibly even put all of those virtual machines in a single server. So in terms of the capital expenditure that we would have, the overall cost that we would have for these things can be significantly reduced if we do something like that. Say, for example, in our environment, we need a router, we need a couple of routers and a firewall and an intrusion detection system. And if we think of all of these things as independent or individual appliances, all of them are going to have particular cost attached to that. But if we are able to virtualize them and put them on a single server, then now the overall cost would be significantly lower. But in addition to the cost advantage, this can also enable us to dynamically deploy these things. Say, for example, if we have deployed, say, a single router here on a virtual machine, now we can duplicate that virtual machine to create a new router. And then we can also do that dynamically if we need a new router. And we can also create additional appliances again when we have a need. And then we can do additional load balancing and so on and so forth. So again, we can scale up and have this flexibility in our network environment, again, based on this. So, and the other one is, again, like performance can also be improved because like sometimes we can have much higher performance routers by not using traditional router appliances. Because sometimes if we need very high like performance from a traditional router, we may need to go significantly higher in cost compared to doing a similar thing in a virtualized environment. And then it can also have additional sort of advantages attached to that. So when we think about SDNs and network function virtualization, so these are two different things. So SDNs is particularly thinking about within these within a particular function of networking. So this is where we are thinking about a router and like decoupling the data plane and the control plane and bringing about the control plane in a centralized manner. So that's what we do with SDNs. Whereas network function virtualization, we are taking the different network functions like firewalls and routers and load balancers and we are virtualizing them, not tied to a particular hardware. SDNs are more end user, so it's not end user, but more about more used in, say, data centers or like anywhere we would use, like not end users as in end users, but more of an enterprise application, so to speak. Whereas network function virtualization is most likely to be adopted by service providers uh, uh, to reduce sort of hardware dependencies and sort of the need to scale up and all that. So um, in terms of, say, similarities, like if we think about the similarities, like say both of them use virtualization in some manner, and both of them would enable us to function in a sort of cloud native environment and software driven networking environment. But the difference becomes SDN virtualizes the network control and forwarding logic, whereas NFV virtualizes the network services and appliances. So it's more of a different level or scale to speak. So if you think like, say, can SDN and NFV be used together in a enterprise network? We can think about an example of a telecom provider who can use SDNs to manage their traffic flows, and then they can also use NFVs to deploy virtual firewalls for different customers and things like that. So they have different applications and they can be used in single in certain environments as well. So when we think about sort of the NFV architecture, so we have, say, the virtual network functions. So these are the functions of, say, routers or firewalls or load balancers. So those are the ones, and they would run within virtual machines. So then we would have the NFV infrastructure. This is the physical, like, computing capability that we would have. So all the storage, network infrastructures, all of those things that are required for the physical layer. So these would be the ones that those virtual functions or virtual machines would sit on top of. And then we need to have some sort of management and orchestration function to interconnect all of those things and manage and provision and all that. So that's the one that would be creating the virtual functions, managing the resources and all that. So that would be the MANO. Now we have SDNs in our networks, but we can also do the same software-defined networking in wide area networks as well. So that's SD-WANs. So it's virtualized WAN architecture and stuff, very similar to SDN. We are separating the control plane and data plane, and we do very similar things in terms of how we manage these and all that. We have a centralized controller, and all those things are very similar. But one of the main sort of advantage or differences of it, where it becomes key here would be how we are able to interconnect between cloud services, and how do we enable routing between these WAN environments, but essentially using software-defined controller to do that. So Within SD-WANs, we can enable some additional um, functionalities, capabilities. So if you think about any sort of enterprise environment, we can have number of branch locations and a data center, but then also can have the internet with different cloud providers and cloud vendors and all that. So if we take an example of a retail chain, a retail like a supermarket chain, they can use SD-WAN to interconnect each of their branches to their head office. And say if they run some of their core business applications like POS systems and some of them run on some cloud vendor, then those things can also be integrated uh, um, um, along with the same SD-WAN or through the same SD-WAN environment. So this becomes a how do you connect becomes relevant. Say, for example, it could be an MPLS connection or a 4G, 5G connection or a broadband fiber connection. So each branch could connect to the internet essentially in any manner it can, but as long as it establishes it's within the SD-WAN environment, now that WAN connection can be managed independently to the underlying infrastructure, similar to how SDNs were doing that thing in a smaller scale. So again, like in terms of functions or capabilities, we will have application-aware routing. So this is where we can prioritize certain applications based on performance needs or business needs. Say, for example, any sort of payment-related functions need to be prioritized compared to any sort of customer, like a staff accessing any sort of internet or some random things on the internet, things like that. We'll have centralized control plane, and then the distributed data plane, similar to SDN. And then we can also have additional sort of local breakouts into direct connectivity into internet. Say, for example, instead of going through the centralized communication, some of the communication can break out independently rather than the SD-WAN. So that can happen locally. Then quality of service, again, like similar priorities and security priorities can be established. And most of all, this can be more optimized for SaaS as applications, like infrastructure as service kind of environments, and sort of it's more in that if our enterprise moves into everything in that direction, this is some of the things that would come into play as well. In terms of benefits from SD-WANs, again, like performance and user experiences could be one thing, because now again, like we can have these additional capabilities around application-aware routing or those things, and they can further reduce latency on certain applications if that's a requirement. Cost efficiency, essentially, because like we don't need to establish a dedicated WAN connectivity between our branches. We can utilize any available transport option, so like a broadband option, and then interconnect our branches and then set up our SD-WAN on top of that. So we don't need to particularly rely on a expensive WAN connectivity between branches. That again, like can reduce operational costs and things like that. Again, like simplified management, because again, a lot of the centralized functionalities, capabilities, again, bring about that. And it can reduce a lot of complexities with traditional WANs. Then in terms of security, again, we can segment the network very similar to how we may use similar things in SDNs. We can do similar things in terms of identity, role, or application. We can use encryption across our communication. And then we can even implement zero trust principles within our environment. And particularly when we are, if we implement local internet breakouts and things like that, again, we can enforce certain controls around that as well. And this could additionally integrate easily with cloud applications. Say, for example, some of our applications are local, and then we have some SaaS applications that are running, and then some of our infrastructure is also in the cloud. So through a certain provider, and now all of these things can be interconnected into a single WAN environment, so that integration becomes much easy. And from a security point of view, there are a number of things that can be done and that could be done in an SD-WAN environment, particularly around encryption and key management. So we can have high frequency key rotations and unique tunnel keys between the tunnels that we establish within this WAN environment. We can even do like decentralized key rotations and then also like data plane isolation within certain environments. Access control and all of these policies can be implemented better or enforced better, and we can enforce secure communication across the network as well. And finally, there's this additional concept around next-gen SD-WAN. So this is particularly thinking about modern enterprise networks that the standard SD-WANs, even they cannot fully address. So these are things around cloud-centric workloads. So we have largely SaaS and as applications. We don't have a lot of local things. Most of them are different cloud-centric applications. Then also different connectivity requirements. So because like sometimes some parts of our organization are broadband connected, some are LTE connected for 5G, and some even thinking about sort of working from home and all those other things as well, depending on the organization and stuff. And a lot of the flexibility or the flexibility that we get from cloud-centric operations can also pose additional challenges to how we would implement SD-WANs, and that's one of the things that a next-gen SD-WAN would address, or that concept would try to address, and some of the additional security requirements as well. So if you had to define what next-gen SD-WAN is, again, next-gen SD-WAN is not a specific thing, it's just thinking about some additional things that could be done with SD-WANs. There are different vendors doing different things, like Cisco, for example, but it's not a single thing. It's not a single function, but it's talking about some additional capabilities. So this is where, again, we could think about AI-driven automation, again, like integration with different cloud providers, different connectivity modes, thinking about zero trust principles and threat detections and segmentations, and then sort of single common management plane, unified management as well. So like as an example, like if we take, say, a international organization with branches in multiple countries, they can use an SD-WAN, next-gen SD-WAN approach to interconnect their warehouses, offices, manufacturing facilities, and then enforce additional zero trust policies and things when all of these things are interconnected. And the end results would be all parts of the organizations are connected, but then who can talk to who can be centrally enforced and managed and controlled as well. So these are some of the outcomes that we would expect from these SD-WANs or next-gen SD-WANs. So and one of the particular ones would be the focus would be around connectivity and security, because again, particularly thinking about larger global environment organization, it would be very diverse connectivity nature in terms of who connects through what, and security again, by the nature of it, it becomes an important factor as well. And sort of finally, what we would need for such SD-WANs to exist. Again, like there are a number of key requirements that we would have, but we would need some type of dynamic routing across all the different transport modes that we can use. So a centralized controller can enable that. And are we able to bypass traditional data center backhauls and go through more SaaS-centric platforms? Again, like prioritizing on business critical applications, integrating sort of identity-based segmentation and continuous trust verification. So this is where how we enforce least privilege across users, devices, applications, and to get zero trust security. And like how we can combine networking and security into like a service platform. So that's where we can enforce centralized policy enforcement, access, and particularly for remote users and mobile users, how we enforce access to them. So these are some of the things, again, in this concept that we would come about. So that's essentially it for the discussion on software-driven networking paradigm. So we mainly talked about SDNs, network function virtualization, and software-defined WAN. All of these things largely is one of the common connecting factor would be virtualizing the network functions or using it in a software, thinking of them in a more software sense rather than hardware and appliance sense. And when thinking about sort of enterprise networks in the next sort of 5 years, these would be some of the key things that we would come across and utilize in enterprise networks than a lot of the traditional networking concepts. So traditional networking concepts are still going to be there because, as we said, the underlying network is still there. We are virtualizing on top of existing networks, but most of our management and utilization is going to be in this virtualization level. So that is going to be one of the bigger factors as well. So that's it for today. Are there any questions? If not, we may conclude for today. Thanks for joining and see you next week.